Bismillahirrahmanirrahim. How are you, dear friend? This is Dishan Gold. In the previous video lecture of set theory, you have learned about properties of union and you prove some properties of union of intersection. Now in this video lecture, we are going to prove some properties of intersection of sets. So there are several properties we are going to prove each one. First of all, you need to know that equality of two sets we have already discussed in the previous video. Two sets are said to be equal if, let's suppose, we have two sets A and B. So A is, if A is a subset of B and B is a subset of A, then we can say that A is equal to B. We will work on this theorem. So property number one, A intersection A is equal to A. As we know that A intersection B is equal to X such that X belongs to A and X belongs to B. So proof, let X belong to A intersection B, we will take element in A intersection A. So this means that X belong to A and X belong to A. It means that X belong to A. This implies that X belong to A. So A intersection B, A intersection A is a subset of A. We take element in A intersection A and it return in A. So it means that A intersection A is a subset of A. Now conversely, let X belong to A. This implies that X belong to A and X belong to A. This implies that X belong to A intersection A. So A is a subset of A intersection A. It means that we take element in A and it return in A intersection A. It means that A is a subset of A intersection A. So by property of, according to theorem equality of two sets, A intersection A is a subset of A and A is a subset of A intersection A. This means that A is equal to A intersection A. This is proof of property number one. Now property number second, A intersection empty is equal to empty. Proof, since A has no common element with empty set, this means that A intersection empty is equal to empty. This is proof. Number third, A intersection U is equal to A. Since A is a subset of U, therefore A intersection U is equal to A, because there will be only element of common of set A with U. So because A is a subset of U, it means that the intersection of A intersection universal set will be set A, because A is a subset of U. So therefore A intersection U is equal to A. This is proof. Number four, A intersection B is equal to B intersection A. This is commutative property of intersection of sets. So proof, we will take element in A intersection B. So let X belong to A intersection B. This implies that X belong to A and X belong to B. This implies that X belong to B and X belong to A. This implies that X belong to B intersection A. So this means that we take element in A intersection B and it return in B intersection A. It means that A intersection B is a subset of B intersection A. Now conversely, let X belong to B intersection A. This implies that X belong to B and X belong to A. This implies that X belong to A and X belong to B. This implies that B intersection A is a subset of A intersection B. So we take element in B intersection A and it return in A intersection B. So it means that B intersection A is a subset of A intersection B. So from 1 and 2, A intersection B is equal to B intersection A. Now property number 4, A intersection B intersection C is equal to A intersection B intersection C. This is a third property of intersection of three sets. So first of all, we will take element in A intersection B intersection C. So let X belong to A intersection B intersection C. This implies that X belong to A intersection B and X belong to C. This implies that X belong to A and X belong to B and X belong to C. This implies that X belong to A and X belong to B and X belong to C. This implies that X belong to A and X belong to B intersection C. Because here is AND, so we will put intersection per and we put union per R. So here is AND, it means that it is intersection. So X belong to A and X belong to B intersection C. This implies that X belong to A intersection B intersection C. So we take element in A intersection B intersection C and it return in A intersection B intersection C. It means that A intersection B intersection C is a subset of A intersection B intersection C. Now conversely, let X belong to A intersection B intersection C. We take element in A intersection B intersection C. This implies that X belong to A and X belong to B intersection C. This implies that X belong to A and X belong to B and X belong to C. Because here is intersection, so we will put AND in each terms. X, this implies that X belongs to A and X belongs to B and X belongs to C. This implies that X belongs to A intersection B and X belongs to C. This implies that X belongs to A intersection B intersection C. So we take element in A intersection B intersection C and return in A intersection B intersection C. So this means that A intersection B intersection C is a subset of A intersection B intersection C. So from 1 and 2 equality of theorems, we also equality of two sets we also know. So this means that A intersection B intersection C is equal to A intersection B intersection C. Now property number 6. This is a distributive property. So A intersection B union C is equal to A intersection B union B. A intersection C, here is A. So first of all, we will take element in left side and it will return in right side, and then we will take element in right side, it will return in left side. So let's take an element, arbitrary element X in left hand side. So let X belong to A intersection B union C. This implies that X belong to A and X belong to B union C. This implies that X belong to A and X belong to B or X belong to C, because here is the union, so we will put R, and here is the intersection, so we will put N. This implies that X belong to A and X belong to B or X belong to A and X belong to C, because there will the element X will be in A and it will be either in B or either in C. So we can say that X belong to A and X belong to B or X belong to A and X belong to C. As the element should need to be in A and B or X belong to A and X belong to C. It means that X belong to A intersection B or X belong to A intersection C. This implies that X belong to A intersection B union A intersection C. This implies that A intersection B union C is a subset of A intersection B union B intersection C. We take element in A intersection B union C and it return in A intersection B union A intersection C. So this implies that A intersection B union C is a subset of A intersection B union B intersection A intersection C. Here is A, not B. This is A, sorry. Now, conversely, let X belong to A intersection B union A intersection C. This implies that X belong to A intersection B or X belong to A intersection C. This implies that X belong to A and X belong to B or X belong to A and X belong to C. No, so here is A is common in both. So we will take common X belong to A and X belong to B or X belong to C. So X belong to A and X belong to B union C. This implies that X belong to A intersection B union C, because here is union. This implies that X belong to A intersection B union C, so we will take element in A intersection B union B intersection C and it return in A intersection B union C. It means that A intersection B union A intersection C is a subset of A intersection A intersection B union C. So this implies that A intersection B union C is a subset of A intersection B union A intersection C. This is proof. Thanks for watching. Best of luck, and please subscribe my channel for more videos. Thanks.